students! Welcome to your science class. Today, we're going to explore another important and exciting chapter, states of water. And in this video, we will focus on states of water and evaporation. Water. We drink it, bath in it, and cook with it every single day. But have you ever wondered how water can turn into ice? Or how it sometimes just disappears into the air? Let's dive in and discover the different states of water and the magical process called evaporation. We know that everything around us is made up of matter, and matter exists in three common states: solid, liquid, and gas. Let's recall what we've learned. In solids, particles are tightly packed and hold their shape. In liquids, particles are loosely packed and can flow around. In gases, particles are far apart and move freely in all directions. And here's something amazing. Water can exist in all three forms. Let's find out how that happens. Water is a very special substance. It can change its state depending on the temperature. And that's where science gets exciting. When the temperature drops to 0 degrees Celsius or below, water freezes and turns into ice, a solid. Between 0 degrees Celsius and 100 degrees Celsius, water stays in its liquid form, just like the water we drink. And when the temperature reaches 100 degrees Celsius, water boils and changes into steam or water vapor, a gas. But why do these changes happen? It's all about heat energy. When water loses heat, the particles slow down and come closer. That's how it freezes. When water gains heat, the particles move faster and spread apart. That's how it evaporates or turns into steam. So, the gain or loss of heat energy causes water to switch between solid, liquid, and gas. Now that we know water can exist in different states, let's look more closely at how those changes happen. Melting. When ice absorbs heat, it melts and turns into liquid water. Boiling. When water is heated to 100 degrees Celsius, it starts to boil and changes into steam. Evaporation. This is when water turns into vapor even below the boiling point, like when wet clothes dry in the sun. Each of these changes happens because of heat. It either helps particles move faster or slower. Now let's focus on one of the most interesting processes: evaporation. So, what exactly is evaporation? Evaporation is the process by which liquid water changes into water vapor, a gas. And guess what? This doesn't only happen when water boils. Evaporation takes place at the surface of the liquid and at any temperature. You see evaporation around you every day. When wet clothes dry in the sun, that's evaporation. When a puddle on the roadside dries up after rain, that's evaporation. When coffee spills on your clothes, it dries after some time. That's because the water in the coffee is evaporating. And when you're sweating and sit under a fan, the sweat dries faster. That's evaporation too. So, water isn't just disappearing, it's changing into water vapor and mixing with the air. So now we know what evaporation is. But have you noticed that sometimes it happens faster and sometimes slower? That's because several factors affect how quickly evaporation takes place. The first and major factor is temperature. When the temperature is higher, the particles move faster, so evaporation happens quicker. That's why puddles dry faster on a hot day. The another factor is surface area. The larger the surface, the more space water gets to evaporate. For example, water on a plate evaporates faster than in a glass. The third crucial factor is humidity. If the air is already full of moisture, there's less room for more vapor, so evaporation slows down. That's why clothes take longer to dry on a humid day. The fourth factor is wind. Moving air or wind helps to carry away the water vapor, speeding up evaporation. That's why sweat dries faster when you're under a fan. All of these factors work together to decide how fast water turns into vapor. Now, here's something really interesting. Evaporation causes cooling. But why does that happen? When a liquid evaporates, it takes away heat from its surroundings, including your skin. This is what creates a cooling effect. Let's look at some real-life examples. When we sweat, the water on our skin evaporates, and in the process, it carries away body heat. That's why we feel cool after sweating, especially under a fan. When we apply alcohol or perfume on the skin, it evaporates quickly and takes heat from our skin, making it feel cold and refreshing. So, evaporation doesn't just dry things, it also cools them down by removing heat. Isn't it amazing how evaporation not only dries things, but also keeps us cool? We've learned so much about water and its wonderful ways. So let's take a moment to recap everything we've covered. Water exists in 3 states: solid, liquid, and gas. Heat helps water change its state, like melting, boiling, and evaporation. Evaporation is when liquid turns into vapor, even below boiling point. Evaporation happens faster when the temperature is high, the surface area is large, the air is dry, or the wind is blowing. And yes, evaporation causes cooling by taking away heat. Water isn't just something we drink. It's always on the move, changing forms, and shaping our world in amazing ways. In the next video, we'll explore how condensation and the water cycle complete the incredible journey of water.